When I walk through a forest, I often wondered how trees can stand so tall and for so long. Most people just see the branches and trunks, but I see a masterpiece of nature engineering, a living system that builds stress from countless tiny architects. When I first place a tiny wood cube into a CT scanner, I feel like I was exploring a hidden city. There are walls, tunnels, and bridges, all once built by living cells. When we take a look at the cross-section of the wood, we can see those tracheids and vessels form a mosaic of tiny faces. Some look surprised, some shy, and some cheerful, as if those emojis are having a nice holiday together. From the scale of a tree to a tiny wood cube, every level tells the different part of a same story, how structure creates stress. What we call wood is actually a sophisticated hierarchy, connecting meters to micrometers in one continuous design. Here in the center, you can see a CT image of European beechwood. It reveals rays and vessels, the main highway and tunnel in this hidden city. But here comes a question that drives my work. When wood is under stress, what are the structures really doing? Are the rays helping holding everything together? Are vessels the weak spot, or actually they are the flexible ones? To answer this question, we combined in situ mechanical loading with 4D X-ray micro-CT, digital imaging, and digital volume correlation methods. Each scan gives us a full 3D snapshot of wood as it deforms. By comparing the softwood and hardwood, rim porous and diffuse porous species, we start to decode the design strategies that nature has already perfected. And when we zoom in close enough, we can see a single cell will buckle and fold. That is the exact moment when the structure creates stress. By understanding the structure intelligence written by nature, we can make a smarter choice. Which local species could be an alternative to the tropical ones? How can we design the next generation sustainable wooden products? And by linking what we see here in 4D CT, from what we know with tree genetics, we start build the whole journey, from the genes that build the wood to the structures to make it strong. And perhaps one day in the future, we can design our future artificial materials as elegant as a tree. When we look back at the cross-section of the wood, we still can find those tiny faces. But this time, they will be smiling back because we finally understand their secrets. Thank you.